Hi, Mr. Becker. So this is my problems for limits. I'll be working them out on the phone and instructing you I learned how to do these. So my first problem is going to be a limit substitution problem. And it looks like this. Lim of x to 4. So for this problem, it'd most likely be easiest to just try and plug in the 4 to see if you could find the limit from that, since it's not approaching from either which side. So you can work it out like this. So I just plugged in the 4, and I'm going to try to solve for the limit of at x equals 4 by just substituting it. And I got both of those numbers by solving out these two different numbers. Make sure it says equals. And then so this limit would equal 11. So when x is at 4, its y value will be at 11. And that's how you solve for that limit, through substitution. So that's like one of the main methods that you can use to find substitution if it's applicable and works. Sometimes it will not work because these numbers will cross out and could become both 0, even though there could be another limit, like in problems I'm going to show you. My next problem illustrates a hole when solving for limits and substitutions. So here it is. This will give a vertical asymptote when I factor this out. See, so you recognize that both of these are the same numbers, so you can cross these out. And that'll allow you to simplify the limit into this. And we can substitute the same thing to find the eventual limit value. I just substituted this x into here to find the limit. So the limit of x at 2 will be 1/4. And since we crossed this out, like when you're making a graph at -2, so at -2, it'll have a vertical asymptote, something like this. And then there'll be a vertical asymptote here because we crossed out this, so that means it cannot equal -2. My next problem that I'll be solving is from limits 2, and it is finding the formal derivative. So the question will be f of x equals 3x minus 6. Let's find f prime of 2 with the derivative formal definition. You start this off by having the formal definition, so f plus and yes, we could just derive it, but that is the next topic we will be learning. So this is the formal definition of derivatives, and we can use this to find the limit of this equation. So first, you need to plug in this equation to the formal definition of the derivatives. So it would go like this. So if this is f of a would be this equation. I have it as f of x, but it could be f of a. And you plug this in accordance with all these, with the letters h. So then it goes out to being this, but that can be simplified, and you put this over h. So then you go down here, this will be lim h to 0, and then you can factor these out, and factor this over, and you'll get 3a plus 3h minus 6, and then you get this second half, minus 3a plus 6 over h. And if these don't cancel out, that means you did the formal definition incorrectly, because you just need to be left with the h's in order to find the limit. So then this would factor to the limit h to 0, and it'd factor to 3h, because this cancels with this, and the 6 is canceled. So it'd be 3h over h, or that just factors out to limit of h to 0 equals 3. That would be your answer. And that's how you find the limit with the derivative, which is much faster and quicker than substitution and everything else. But that's only applicable when you can actually use the formal definition limit. So this is the question right here, limit of 0 sine x over x. And this one is basically a need to know, because there's so many problems that could be built off of this, like different numbers going in right here and right there, that you can find the answer in this very simply and quickly. The answer, there is a very long geometric way that you can find the answer, but it's easiest to be explained by just graphing it. So when you graph the sine wave on an equation, right, a normal one would just look like this. And you sort of have that here, like the down, up, but it's going to go on forever on this thing. And you're just trying to find the limit when it's at 0. So you know when you plug this into your calculator or you just graph it, it'll start at 1 and work its way down, up and down, and up and down, and up and down, and up and down. And it keeps going and keeps going. So when you substitute the 0 in for that, sine of 0 equals 1, so you get that. And that's basically it. So your answer is going to be 1 when it's at 0. And also when it's at infinity, it will be approaching 0, but at an infinity level. And then my last one's when you find a limit graphically. So this is the limit right here, and this is just a graph with a hole right there and a point at that instant at f, or x equals 1. But so this limit is approaching 1 from the negative side. So you know when it's approaching 1 from the negative side, it's going to be, the limit's going to be 2, because when it's approaching from the negative side, this is 2 right here on the graph. And you know that when it's approaching it, it's getting super, 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 super close, but it's never actually touching that. And you can use the table chart value too to figure this out, because when the limit is at 1, it will be at that point, but it won't be there because it's the actual points below the graph at -1, so you know it's -1. But right up to 1.001, that limit's going to be 2, because it's approaching it, but it's not hitting it. So basically, you know when, and then if you go like this, 1.1, then it's going to be a little bit higher, maybe like 2.05, And same thing on the other side, 0.99, you know that it's going to be, or 0.199, no, 0.9, because it's the x value. So when it's like right here, you know it's going to be like almost there, so maybe be like 1.999, you know, and same thing. And so when you gradually approach it, it'll be around 2, but then at that instance, it'll be at 1. But since you know that it's approaching from the right side, then you know it'll be 2, because it's never actually hitting 1. It's never actually on the 1, it's just approaching it. So therefore the answer of the limit would be 2, because it's approaching from the other side. And limits can exist at holes too, so even if it was, you can say that that would be the limit too. And that's it for my topic of limits. I'll be doing derivatives next.